In this video, I'm going to show you how to mount an EFS to the EKS Fargate cluster. To demonstrate, I have created a sample.NET Core API which can post file to the server and an active EKS Fargate cluster. In our sample application, I have created a folder named access files to store uploaded files. While building the container, I have added an additional steps to create the folder and set the volume in the same name. Switching to the cluster information, uh, let me refresh this. You can see I have already created one cluster under the name EKS test, and under the resources workloads you can see a number of ports are running, uh, and I can explain what all this thing. So these two ports are refers to the AWS load balancer, and this is called DNS, and these are the two application ports. So this application is up and running, and this video is not and this video is only intended for EFS integration. I'm skipping the steps for EKS cluster creation. However, you can find the relevant files from the sample application which I have showed you earlier, which will help you during the creation of both the cluster and the EFS. I will include the GitHub URL. So here you can see the GitHub repository where I have checked in all the files which are associated to the sample application and the commands that we have used for. And for the EFS integration, I also added the commands which will be useful for during the creation or mounting, create both the creation and mounting the EFS to the EKS cluster. Since our sample application is up and running right now, let me show you how the system work right now with before mounting the EFS. So to demonstrate, I'm using Postman to upload one sample application to the to our server. I have selected one sample file over here, and I'm sending the request. Let's wait for some time. Yeah, now I got a 200 OK response. Let me switch to PowerShell script, PowerShell window. Let's see the name of the ports. Kubectl get ports, and all the ports are running under a specific namespace. So I'm filtering the namespace I'm using. So this is EKS test. Okay, so these are the name of the ports that are currently up and running right now. Now we have to go to the folder inside the container. This is the command which I'm going to use to explore the container folder. So we have to use the name appropriately. So this is this command I already have used earlier, that's why. So let's see what it is there. Okay, we don't have that uploaded document in one pod. Let's see the status of the other one. Okay, now you can see the uploaded document is already there in the second pod, and which is not in the first pod. So this has happened based on the the ALB that we have configured, and what it makes sense, it is not referring to a shared folder. So it is saving the uploaded file in the container itself. So this is the status of before mounting the shared volume. Now let us begin the steps for mounting the shared file system. Before we commence, let me give you a brief introduction to the EFS. Amazon Elastic File System is a cloud storage service provided by AWS, designed to provide scalable, elastic, concurrent, with some restrictions, and encryption also supported in EFS. It supports both NFS version 4.1 and NFS version 4.0 protocols. EFS offers a range of storage classes designed for different use cases. So during the creation of EFS, you can select whether it's a standard storage class or once-on storage class. The standard storage class is EFS standards, that EFS standard infrequent access, which offers multiple availability zones, and once-on storage, from the name itself, it's which is clear that it is focusing only one zone rather than multi-zone. Anyway, I will add the documentation link, the official AWS documentation link, in the video description. In this video, I'm only using the console, AWS console, and I'm not explaining any AWS CLI commands for both the creation as well as mounting. You can refer the commands from the GitHub URL which I have created, so you can get familiar with both of these steps. So right now we can focus on the console. So let me search for EFS. Okay, we have EFS. I'm opening. Okay, now it's loaded. Go to the file system. Right now I don't have any resources, so let's create one file system. So the name is optional, though I'm giving EKS test. And the next thing is selecting the VPC. Since I haven't included the steps for creating the EKS cluster, you can imagine that the VPC which I'm going to use here would be the same one which we have created for the cluster. So this is the one which I have already created for the cluster. Now select this. We have two options, like I mentioned before. One is standard and one is one zone. So in the standard we have the multi-availability zone setup, but the one zone will be focusing on the single availability zone. Let's create it. It may take some time. I'm pausing for some time. You can see the file system status is created. Oh yeah, it got available right now. I don't have to stop right now. Okay, let's see the attributes of the file system which we have created for. So along with the name that we have given, we can see the ID, the file system ID. So every file system which we are creating will have a unique ID. So this is the ID which we are going to use when we are mounting the file system to the container. So here you can see that a general purpose performance mode and backup is enabled, and which is the file system state is also available. And there are numerous tabs available. So this is something like we don't have to sometimes we have to monitor the size which the EFS has consumed right now. So you can use this tab to for that purpose, and we have a monitoring. This also have numerous metrics available. Here you can see the throughput, utilization, IOPS, throughput by type. Also you can change the mode to single value. So this is the one which I have preferred right now. So since this is a newly created one, we don't have any numbers or figures here. And access points. So this access point which refers to the EC2, like if you want to mount the EFS to the EC2 instances, then we can use these access points. So I'll show you. We can create one for this purpose, though we are not going to use it for the integrating to Fargate. So that name is optional, and the file system which we can see that which is already selected with the one which we have created for. And if you want to set the POSIX users that is supposed to use the that EFS, we can configure. I'm skipping for this time. Also the root directory creation, I'm skipping all these things. Okay, now we have that access point. If you click on that access point, if you click the attach, then we can we will see the command that we can use for mounting the EFS to the EC2 instances. Let's skip this and go to the file system. Okay, the other tab is network tab. So this is really important. Like we can see the availability zones right now, and I have created 2 availability zones. So this is also mounted with 2 availability zones and mount target ID and the subnet ID. So this means, like, if you want to make it available for the availability zones which we have created, then we have to mount to the specific IP addresses that we have created for. So these are the IP addresses that we have used for mounting to a specific availability zone. We may get some errors during the creation, that sometimes it might be like if we are loaded with lot of services in one single availability zone, and that is not able to allocate any IP addresses to the EFS, we may have some issue, and which would be common for other services as well. And the security group right now, which is selected the default one. If you want to create a new one, we can use that as well. And the replication, we don't have any replica right now. Okay, and this is not intended to have any replica since it's not shared to the other regions as well. Let's start mounting the EFS to EKS Fargate cluster. So now we have the active file system over here. Let's move to the cluster. Now we have this, still the apps are running. If you go to the configuration, you have to configure 3 things before we mount the EFS file system. The first one is storage class and persistent volume and persistent volume claims. So these 3 things helps the Fargate to determine the EFS file system and mount it. This mounting is happening through driver, EFS CSI driver. So this driver, if you're mounting EFS to the EC2 instances, then you have to manually install this driver, then only this mounting will happen. So that section you can see CSI driver here. However, the serverless Fargate automatically detect this driver with the built-in configuration and will make this mounting available once these three things are configured properly. So I have created a YAML file called storage class, which is already available in the GitHub repository. This just we have to mention we have to use the CSI driver for this mounting, and I have a kind storage class where I have named the EFS CS, and if you are a namespace, if you are using a namespace, better you mention the namespace here. But here we can find the namespace for some of the items which is not supposed to have that property, but I have added this to make sure everybody to understand this is happening in a particular namespace. And the professional, I have mentioned EFS CSI AWS.com. So AWS has other file share system called EKS. So we have to specifically mention like we are using EFS. And this is the persistent related claim. And this claim is also have this namespace, and you have to mention the access points, which is a read-write claim. Also, this is linked to a storage class called EFS C, which we have already created over here, and the mounting request we can specify the storage as well. The next one is persistent volume. So this is mapped with storage class. Here we can find the storage class, and the specification we can mention the capacity and the volume mode is file system, and access mode is still read-write supported, and reclaim policies retain if the EFS is encrypted. So by default the file system is encrypted, so we can make the options like that mount option, we can mention TLS. The last one is specifying the CSI, and the driver still we have to mention like EFS, and the volume handled we should have the file system ID. So I'm going to fetch the file system ID from the console. So this is the file system ID, and I'm copying it, pasting it. Now save this one. The next thing, we have to run this YAML. qctl file storage class. I'm going to run this file. Oh, sorry. You can see the CSI driver and the storage class, which is marked as unchanged, because as part of my initial creation I already have this in place for that particular cluster, so that's why it's marked as unchanged. But you can see the claim and the persistent volume is created with the settings that we have provided. In management console, if we go to the configuration section and click on the persistent volume, we can see that the newly created persistent volume and claim is available. Let's confirm this in PowerShell script. So in PowerShell I have executed kubectl get pv EFS -pv. This is the name of the persistent volume that I have created. So here you can see the result. You can check for the status is bound. So you have to wait for the status to be turned to bound before you execute. Likewise, you can check the persistent volume as well. So this is a command for getting the status of persistent volume claim. I'm going to execute this. EFS claims is not found, probably it's claim. Yes. Now you can see the status is bound, and which is bounded to the volume EFS dash PV, and the capacity which is we have provided, and the access modes you can find or read write. This is bounded to the storage class as well. So now we have done the configuration. So since there are multiple ports are already running, we have to delete it. The Fargate will provision new ports for us. But before that, we have to mount the volume for the ports, right? Then only it can access it. So for that, I'm switching to the application. So here I have created another YAML file for the deployment, namespace, and services. So this you can use during the creation of EKS cluster as well. Here I have commented few section. So this is the would be useful for mounting the volume. So I'm commenting it. Here in this section you can see that the volume mount is the persistent storage. So I just gave a name, a persistent storage. The name can be anything, but you have to make sure the name which you have provided in the volume mount should be similar to the one in the volumes. Okay, so there are a list of volumes you can mount, but this I have only one. That is the name persistent storage, and the mount path is app access files. And under this volumes you can see that claim name is EFS claim. So these are the two things that we have to do. Let's run this first. Switching to kubectl apply EFS. Let's wait for some time. Okay, this is executed, and you can see that the deployment file is configured since this is changed. Let's go to the console, refresh it. Okay, under the workload, if you get the ports, and you can see that the extra deployment node is being configured, okay, a few seconds ago. Probably we can wait, or we can even delete everything and let it start again, but we will wait for some time. I'm pausing till it configure everything. Okay, now in my next refresh we can see only 2 ports are running. So if you click on the port, we can see that this is running, and yeah, it started. But let's expand the container. We can see the mounts from the persistent storage which we have enabled right now. Let's test it. So I'm going to test it. So this is the URL is not changing since we haven't reconfigured the ALB. Let's send it and test it. We are getting a 200. Okay, go to the EFS under the monitoring. So in EFS monitoring, we can see that there is an open client connection is available, and the percentage IO util limit is changed from 0 to 0.01%. So something has happened in between. Let's confirm this in command line. Okay. So before that, we have to uh, list the port names. So kubectl get ports, and let's filter using the namespace EKS test. 2 ports are running. Now we have to, yeah, this one. Let's check with these ports. Okay, we will check with the first port. Okay, so the document which we have uploaded is available in the first port. So if it is a shared file system, then it should be available in the second port as well. I'm copying the name of the second port. Yes, the file is available in the second port as well. So which means they are pulling the documents from the same shared file system. In order to make this, I believe I have skipped one more step that would be useful, but it was already configured in my VPC. Like under the VPC for EFS network, we have its network. We have a security group, right? 5B3. So under the VPC security group, security groups, (5B3) is the default one. Let's open this. I've already configured one inbound rule. So this is also a mandatory step, what I think which was already there since I have started this video. So you have to configure this type NFS. So the port range is 2049, which will be added default while you're selecting this type. And you can give the name of the security group of the cluster, the which we have created. Okay, that is the only last step that you can follow along for making it work. So all the commands which would be useful for creating or mounting the EFS would be available in GitHub repository. You can use it. Thank you.